Hi guys, welcome back to part 2 of this series of videos which is going to lead us to simple linear regression. We talked about bivariate data which is essential in understanding the underlying data sets that we're going to be considering here in this module. So we talked about bivariate numerical data specifically, and one of the first things that we can do in trying to explore the relationship between an x variable and a y variable, both being numerical of course, is to create what's called a scatter plot. Okay, so usually we want to make some kind of chart or plot first thing before we start calculating too much. So the chart that we would like to construct here, if bivariate numerical data, is a scatter plot. Okay, and this is the most important graph based on bivariate numerical data. Okay, so basically it looks like this. So we have a x-axis and a y-axis here, right? Not different than the Cartesian plane that you're used to seeing in your algebra and pre-calculus and calculus courses. Okay, except we're focusing on the first quadrant here because most of the variables we're going to be dealing with are going to take on positive values for both the variables, so we're just focusing on that region. But it's very possible you can have a negative variable that creeps into the other quadrants. Okay, but most of the time scatter plots rather are going to look like this. Okay, so let me plot a couple points here. Let me use a different color here. So I'm going to just randomly plot some points just as an example of a scatter plot. All right. Now, each one of these points represents one observation from our data set. So this guy right here, if I circle him, that is one row in that data that we considered in the last video, where we had an x and a y, and one row represent one observation. This is a visual representation of this data set. Okay, so you can guess how many rows we're going to have, how many points we're going to have. If we have n rows, we're going to end up with n points, one for each one of these observations. So if you actually go through this data and the points and count them, you'll know what the sample size is. Okay, so what can we learn from the scatter plot? Well, there's a few things. We can break it down in a very systematic way, and once you see a bunch of these scatter plots, you will get better at reading them. First off, most important thing is the direction of relationship between the x variable and the y variable. Okay, so as far as direction is concerned, we're talking positive, negative, and sometimes null, meaning no direction. There's no clear direction. So we'll confine our choices to one of these. Okay, the one we're looking at here clearly shows some kind of positive direction, right? The general pattern is what we're considering here, not the individual noise of the points, because if you were trying to do that, you'd end up with a very squiggly line which is focused too much on the details, the noise, than on what we're really after, which is capturing the pattern of the data. Okay, and if you consider that, you can abstract away that noise, you can quiet that noise away and get the signal. And the signal is, for me at least, it should be intuitively clear for you, is that these points are flowing in this direction, and that's a positive direction. Okay, that's in this example. 2, a scatter plot will also reveal the direction, as well as the direction, the strength of relationship between an x variable and a y variable. So for direction, for strength rather, we'll think very subjectively at this point. Strong, moderate, weak. Okay? And until we see a couple of these plots, it's going to be difficult to make this call. Once we have a few to compare and contrast, you can get a sense of which ones are stronger and which ones are weaker and which are just moderate. Okay, so we'll hold off judging this guy on strength for now. 3. The shape of the relationship. So let me just say shape of relationship between x and y. And for shape, we're really considering two possibilities: linear and curved. So linear means a straight line. So a line that is straight, which I'm trying to do there, is linear. Whereas any kind of curvature, any of this, no matter how dramatic, is curved. Okay? We're only going to consider linear relationships. Okay? So the one we're looking at here is clearly linear. Now I'll warn you, don't look for curvature if it's not there. You sort of have to blur your eyes and focus on the general flow of the points instead of getting too attracted to any particular detailed flow. Okay? I will show you an example of a curved relationship, and it should be pretty obvious that there is curvature. Okay? And finally, a scatter plot will reveal to us what are called outliers. These are points that just don't look like they sit right with the rest of the points on the scatter plot. So in our example, we don't seem to have any, but if you would allow me to just add a point here, for example, this flow is definitely not working for this point. This point seems to be sitting outside of the general pattern. And so this would make me a scatter plot would make me kind of look into this point and ask myself, does it really, is there some kind of mistake here, or is this just a freak case which I need to figure out how I want to deal with? Sometimes I might want to delete this guy and not make him influence the rest of my analysis. Sometimes he might be important, this point, just to realize that there was some error in the recording process. How I deal with the outlier is a very kind of complex and specific to the researcher's objectives. So for us, just the fact that we'll be able to find an outlier like this or maybe like this would be enough, okay, to identify them. Okay, before I go on to show you a bunch of scatter plots, just looking at this one here, notice, let me just make these points a little bigger. Notice that and I'm adding a few points if you would allow me. Notice that at any particular x, so let me just choose a different color. Let's just take x here. Okay, so this is just, for lack of having a number, this is just a particular value for x. It's one of the possible values. Now look straight up on this line of x. Okay. You notice that there's a bunch of different points. If I didn't actually touch those points, that's not the point here. The point is that they're very even close to this x along this dotted vertical line that I drew. There's a bunch of different points. Each one of those has its own y value, right? I don't want to draw them, but you can see kind of the phantom lines I'm drawing. So what I'm trying to show here is that the value of y is not determined solely by the value of x, but by various other factors as well that maybe we're not considering. So knowing, if we make this example age be x and y be height, like the mini example we started in the last video. Now, I would say at a particular age, let's take a particular number here. Let's say at 17. Well, if I tell you someone's 17 years old, can you tell me for sure how tall that person's going to be without knowing which 17-year-old I'm talking about? No, obviously not. So that's what I was saying using the x's and y's. You can't determine someone's height, that's the y in this case, just by knowing their age. Right? Because notice that at any particular age, now I just chose this x. Notice if I could have chose x here, right? And maybe this is a 15-year-old. So just go up on this x. Notice that at both of these x's and at any other x's and any other age that I chose, that there's going to be variability in the y's. Look at this. Look at the y's close to this dotted line, and here as well. Okay, there's a scattering, so you can't tell me what y is going to be just by knowing x. All right, so but that kind of makes it sound like we're doing something futile. But you see that there's a clear pattern that if I know what someone's age is, then it does give me some information about their height. Namely, I know that as age increases, height increases. So if you gave me someone's age, I would definitely be able to use that information to make a much better prediction or estimation of how tall that person is without actually measuring their height. But I can't tell you exactly what that height is going to be. And that's really where we're going with all this. We're trying to learn the pattern, the flow of the points, and from what we learn, we can use that information to make predictions and estimations about the y variable from the x variable. But don't confuse that with trying to, with being able to determine the y variable from the x variable. I can't tell you how tall someone's going to be if you give me their age only, but I can give you a very good estimation because in this whole process that I've started so far, I've already started to see that older people tend to be taller, at least within the ages that we're looking at. Okay? So that's definitely going to be useful information for me to make a better prediction of their height. Okay? So that's all I want to say about this particular scatter plot. Let me show you a few examples of different types of textbook scatter plots that you will come across, give or take, and interpret them. Okay. So this guy right here is an actual scatter plot based on data that we already saw. Let me call this the y variable because I plotted it on the y-axis. And let me call this the x variable because I plotted it on the x-axis. Okay. So if you actually go through and plot these points, there are 10 observations here. So n was 10. And you'll notice there are 10 dots here, or points, in this scatter plot. Okay. So let's judge this scatter plot based on those 4 kind of revelations. Okay. First off, what's the direction of this relationship? Well, let me use another color to kind of intuitively draw the flow of this pattern. The flow of this pattern is like this, right? You all would have drawn a similar line, slightly more steep, slightly less steep, slightly higher, slightly lower, but generally we'd all agree that this is the general flow of this scatter plot, of this relationship. So this is definitely a positive relationship, right? 2, what's the strength of this relationship? Well, it looks, for strength, we have to give you some contrast, but you could think, how close are those points to each other in this flow? I would say this is definitely, at this point, we could say something like moderate to strong. Okay, more on this to come, but just for now, think of the strength as how tightly packed the points are in the flow. Okay? If they're loosely packed, it's weaker than if they're tightly packed. 3, the shape. Well, there's no need to think that there's any curvature here unless you're focusing too much on the individual points. So this is a linear pattern. And the line that I drew from my gut, from my intuition, also corroborates that fact, agrees with that. And 4, there's no outliers really to speak of. A point out here or out here might be something I would look into. Even a point here. Okay, so it's very subjective, so no outliers to talk of. All right, and you see clearly that although there's only 10 observations, so there isn't a lot of data to work with, that at any square foot, so let's pick somewhere where there's some density in points. So something like 1,600 square feet, there's a few kind of points for price. So just because two houses are the same exact square feet, that doesn't mean they're going to sell for the same amount, right? Obviously, there's going to be other factors that are going to play a role into determining the price of a house. We're only considering one of those factors, the variable square feet. So we are not surprised to see that there's variability at any particular X value. Okay, it is, after all, a scatter plot. Okay, now in part 3, I'm going to go into another tool available to us in addition to scatter plots to start to learn more about this relationship between these two numerical variables.